Hi, I'm Bob. Welcome back to 5-Minute Econometrics. Today, we will explore how to draw the fitted curves when the regression model contains an interaction term or a quadratic term. In these cases, the relationship between the outcome variable and the explanatory variable is not linear. The fitted curves could bend upward or downward. In other words, the marginal effect of x on y is non-constant. It changes with x. A graph is usually a good way to show this relationship clearly. There are two types of curves we can draw: estimated outcome curves and marginal effect curves. We will discuss both when the model includes quadratic or interaction terms. In previous videos, we have already discussed quadratics and interactions in regression models. Check those out for more details. Take the model that relates hourly wages to work experience and education as an example. When we use the quadratic terms of years of experience and education in the regression model, the fitted curve is not a straight line. The estimated hourly wage increases with experience at a decreasing rate. So the outcome curve bends downward. In Stata, we use a double hashtag between variables to include both the level term and the interaction term in the model. When the two variables are the same, it means both the level term and the quadratic term of that variable are included. In our example, the range of years of experience in the model is from 1 to 51 years. We use Stata's margins command to calculate hourly wages at every 5 years of experience. With the fitted values, we then use the Marginsplot command to draw the fitted curve. To make the graph more informative, we add options for title, axis labels, curve color and style, and confidence intervals. The estimated hourly wage increases at a diminishing rate and eventually decreases as work experience rises. Another way to show the same information is to draw the marginal effect curve. The marginal effect equals the slope of the outcome curve. An estimated wage curve like this one implies a diminishing marginal effect of experience on wages. As workers gain more experience, the marginal effect decreases. In Stata, we use the dy/dx option to calculate the marginal effect of experience on wages at specified years of experience. We calculate marginal effects every 5 years. Then we use Marginsplot with options to visualize the marginal effect. It decreases with years of experience, and at about 28 years, the marginal effect becomes negative. This corresponds to the peak of the estimated wage curve we just graphed. We can also draw both the estimated outcome curve and the marginal effect curve for education. Education shows an increasing marginal effect on hourly wages. Now, consider the model that relates workers' hourly wages to their education and family background. The explanatory variables are the workers' years of schooling and their parents' average income during childhood. Parents' income is a binary variable, 1 for high-income parents and 0 for low-income parents. We want to know whether the return to education differs between workers from different family backgrounds. Using a double hashtag between the two variables includes the level terms and their interaction term in the model. The interaction term is statistically significant at the 5% level. We use the margins command with the add option to calculate estimated hourly wages for different values of education and parents' income. Then we use Marginsplot to draw the estimated outcome curves. Both groups of workers have positive returns to education. Wages increase with schooling, but the slopes differ. For the same years of schooling, individuals raised in more favorable family environments earn higher hourly wages as adults. The same information can be shown with marginal effect curves. The slope of the estimated outcome curve is the marginal effect. Since there were only two groups of workers, we have two different marginal returns to education: 0.125 for high parent income workers and 0.106 for low parent income workers. We use the dy/dx option again to find the marginal effect of education on wages, and the add option distinguishes the two groups. Finally, Marginsplot visualizes the two marginal returns to education. The previous example involves one continuous variable and one binary variable. If the interaction term is constructed by two continuous variables, we can still draw marginal effects using Marginsplot. Suppose we use the continuous variable log of parents' income in the model. The double hashtag includes years of schooling, parents' income, and their interaction term into the model. The margins command with the dy/dx option gives the marginal returns to education. The add option specifies values of parents' income, in which we evaluate the marginal effects. We choose the entire range of log parents' income. Then Marginsplot draws the marginal returns to education curve. It increases with parents' income, implying that education and favorable family background reinforce each other. Visualizing the estimated outcome for an interaction by two continuous variables is more complicated. In 2 dimensions, we can use color to illustrate a third variable. The Stata command contour produces such graphs. We first use margins command to store predicted values of log hourly wage across years of schooling and parents' income in a new dataset called predictions. Next, we open the new dataset and type graph two-way. Inside the brackets, we write contour and the corresponding values of the variables. The levels option specifies how many contour levels to draw. The 2 explanatory variables, years of schooling and parents' income, are on the x and y axis. The color of the z-axis illustrates values of the estimated outcome variable, log hourly wage. We find that for the same parental income, higher education is associated with higher wages. For the same education level, the workers' hourly wages are positively associated with their parents' income. Today, we have discussed how to draw the estimated outcome curves and the marginal effect curves when using the quadratic or interaction terms in the regression model to capture the non-constant marginal effects. To visualize the estimated outcome variable, we use Stata's margins command with add options and Marginsplot, or the contour plots for interactions between 2 continuous variables. To graph marginal effects, we use the margins command with dy/dx option and then Marginsplot. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.